Hi guys, here is your lesson on operations on functions. So let's say we got a function like f of x is equal to 3x plus 2 and g of x is equal to 2x minus 4. We can actually do every operation, addition, subtraction, multiplication, division, with your functions. So let's say I wanted to take f of x plus g of x. We've actually already done this before with polynomials, it just wasn't written in this format. Another way I can write f of x plus g of x would be f plus g of x. So that notation means exactly the same thing. And all we do would be to take, okay, well f of x is 3x plus 2. G of x is 2x plus 4. I'm going to add those together. 3x plus 2 plus 2x minus 4. Combine like terms. So at 3x and 2x I got 5x. And a 2 and a minus 4 would be minus 2. So I would say that f plus g of x equals 5x minus 2. Do we have any restrictions on the domain? Well, looking at this, at our answer, no. At the original functions, it looks like x could be anything. So for adding f of x plus g of x, we could say that our domain is negative infinity to infinity, and we still need to use the interval notation. You're welcome. But let's see if our domain is affected on any other operations. Let's take a look at that same set of rules. So f of x we said was 3x plus 2, and g of x was 2x minus 4. Let's take a look at f minus g of x and state any domain restrictions. So this is equal to f of x minus g of x. So that will look like, let's see, f of x is 3x plus 2 minus, be careful because I'm subtracting the entire quantity, of 2x minus 4. So we'll have a 3x plus 2 minus 2x minus minus 4, or plus 4. And then we'll combine like terms again. So the 3x minus 2x, just an x, and 2 and 4 is 6. I still don't see any domain restrictions, so my domain here is still negative infinity to infinity. X is defined in my original functions, and I have to look at both of them. I have to take restrictions from both f of x and g of x. No restrictions here. What about in f times g of x? That would be 3x plus 2 times g of x, or 2x minus 4. So, exciting, we get to FOIL. So what's that? 6x squared minus 12x plus 4x minus 8. And in combining like terms, we'll have 6x squared minus 8x minus 8. Looks like my domain is still negative infinity. Oh, sorry, I'm running out of space, to infinity. What about when we divide? So in the division, I'll have f of x divided by g of x, which we could also write as f over g of x. Again, you'll see either of these notations. They mean the same thing. So for this function, that would be f of x was 3x plus 2 over g of x, which was 2x minus 4. And I can just leave my answer as this. However, I do have a domain restriction here. What value of x makes the denominator 0? If we're not sure from looking, I'm just going to set the denominator equal to 0 and solve that equation to know what x can't be. X can't be 2. So in interval notation, my domain for this would be negative infinity to 2. I can't include 2. Union 2 to infinity. So we've just seen all of the function operations and domain restrictions for each operation. Let's take a look at another example. Let's take a look at another example. In this problem, let's say that f of x equals, let's pick a good one here, the square root of 1 minus 2x, and g of x equals 1 over x. I can already see some domain restrictions. Without even doing any operations, I know that x can't be all real numbers here. Looks like, let's see, under the denominator, 1/2 would make that 0, which 0 is okay under the radical, but let's think about values. We know that 1 minus 2x has got to be greater than or equal to 0. So in solving this, let's see, 1 is greater than or equal to 2x. So 1/2 is greater than or equal to x, or x is less than or equal to 1/2. So there's my domain restriction on f of x. I already have that before I do any operations. And then here x can't be 0 because we can't divide by 0. So these domain restrictions are in place already for every operation. So if we were to take f of x plus g of x, let's change colors here, the square root of 1 minus 2x plus 1 over x. Not much to do to simplify here, so I'm just going to leave it at this, but I've got to state that my domain here, including both of these, I have to include both f of x and g of x because they're both in this expression. So I've got to be less than or equal to 1/2, but I also can't be 0, so that means we can go from negative infinity up to 0. I can't include 0. Union, not including 0, so skip 0, up to 1/2, and I can't be any more than 1/2. I can include 1/2 because that would just make f of x equal to 0, which is totally fine. So I've got to state my domain restrictions for every operation. This was just addition. If I go to subtraction for these, so if I take f of x minus g of x for the same functions, we had said that f of x was the square root of 1 minus 2x, and g of x is 1 over x. Same domain restrictions. So the domain we had said was negative infinity up to 0, union 0 up to 1/2, including 1/2. Multiplication, f of x times g of x is going to look very similar. The square root of 1 minus 2x times 1 over x. As simplified as we can get would be the square root of 1 minus 2x over x. Same domain restrictions. I still can't be 0, and I still can't be more than 1/2. So again, I state my domain. The domain is the same again. And it should be the same in division. If I take f over g of x, that'll be the square root of 1 minus 2x over 1 over x. Scary, but remember I just flip the denominator and multiply. So that will look like x times the square root of 1 minus 2x. Same domain. So if you see at the end of a problem that the domain is going to be all the same, you could write same domain throughout. I just want you guys to see that I'm stating it every time. If it's exactly the same, you don't need to write it every single time. Just indicate that the domain is the same for every operation. Okay, let's throw in some numbers. Let's say we got f of x to be x squared plus 10, and g of x is the square root of x minus 1, and I want to evaluate f plus g of 2. Well, what does that mean? Well, that means I'm going to evaluate the f of x function at 2 and g of x function at 2. So what that really means is taking f of 2 plus g of 2. So I'm plugging in 2 into the f of x function, and I'm plugging in 2 into the g of x function. So f of 2 will look like x squared, so 2 squared plus 10, plus g of 2 is going to be the square root of x minus 1. Well, x is 2, so 2 minus 1. And then we're just going to simplify. So this is 4 plus 10 plus the square root of 1. 4 plus 10 plus 1, which will give us 15. I don't have to worry about any domain restrictions or anything like that here because I'm evaluating an actual number. So I don't have to worry about that domain because I'm plugging in one specific value for x. So this is our main piece on function operations. We are going to look at composition of functions. Ooh, functions of functions tomorrow.